This video will be about the asymptotes of rational functions. There are three types of asymptotes we'll look at. Vertical asymptotes, which will never be crossed. Those go straight up and down. Horizontal asymptotes, so straight left and right. These can be crossed toward the center of a graph, but they determine what happens on the far edges. So as x gets really big and x gets really small, the horizontal asymptote will start taking over. The same happens if instead of a horizontal asymptote, you have a slant asymptote. So the only difference there is it's no longer completely horizontal left and right. It has a slightly different slope. For now, let's focus on vertical asymptotes. The first step you want to do is, of course, factor the numerator and denominator. And unlike domain, you do want to simplify the rational function in this case. So when we factor, if there's anything in common between the numerator and denominator, you do want to simplify that. From there, once again, determine where the denominator is 0, and those will be your vertical asymptotes. Now, for our first example, let's find the vertical asymptotes. So VA for vertical asymptotes for f of x equals x minus 4 all over x cubed minus 2x squared minus 16x plus 32. Now, once again, you want to factor both the numerator and denominator if possible. So for the numerator, he's already simplified. So numerator, he's x minus 4. That's easy enough. Denominator, though, is going to require a little bit more work. X cubed minus 2x squared minus 16x plus 32. Now that that's more legible, notice there's 4 terms. So what I can do with these 4 terms is group them. So group the first 2, group the last 2. These first 2 both have an x squared in common. So that's what I'm going to pull out. That will leave me with an x minus 2 in parentheses. Now, I have to figure out what to pull out of negative 16x plus 32 to get me an x minus 2 in parentheses. So if I pull out a negative 16, that should get me something. So negative 16, let's see what it leaves me inside. So negative 16 divided by negative 16 is just x. 32 divided by negative 16 is negative 2. Now, from here, notice both terms have the x minus 2. So I'll factor that out, and that just leaves x squared minus 16 in parentheses. Well, we're not done just yet. I can keep factoring this guy here. X squared minus 16 is a difference of squares. So when I finish all factoring, x minus 2 is still there. This is going to become x minus 4, x plus 4. So what I actually have for a function is the following. We have f of x equals x minus 4 all over x minus 2 times x minus 4 times x plus 4. Now, we've factored. Our first step is now to simplify. I'm left with a 1 up top, and then this guy cancels as well, or simplifies. So for vertical asymptotes, you're only going to focus on these two. So for vertical asymptotes, I'm going to focus on x minus 2 equals 0 and x plus 4 equals 0. So I'll add 2, we'll subtract 4, and in our cases, our vertical asymptotes will be x equals 2 and x equals negative 4. Be very careful. Vertical asymptotes are lines, so each one needs x equals with it. So when you write these out, it's going to be x equals 2, comma, x equals negative 4. You've written the two lines, you have your two vertical asymptotes. Now, what happens with these two? So, this isn't going to give you a vertical asymptote, but it does give you something interesting. That x minus 4 that we canceled out, so the x minus 4 that was canceled, actually is a hole in the graph. It's a form of discontinuity which we like to call removable discontinuity. The reason it's removable is because we canceled something out and that's where it disappears. So it's removable, but it's still a hole in the graph, which you guys have probably seen before as something like the following. All of a sudden there's a hole in the graph and then it keeps going. That hole, in our case, would be something along the lines of removable discontinuity. This is not the graph of the function we just did, so please be aware of that.